Okay, so today we're talking about the idea of incorporating ergonomic principles into project design. This is a really interesting topic that I always enjoy speaking on, mostly because it's a piece of our industry that ultimately gets, in my opinion, gets overlooked a lot, right? That we are often being called in and asked to be involved in the injury management side, right? So we're completing physical demands assessments and ergonomic risk assessments, often for injury prevention or because there's already been an injury and they're trying to bring someone back to work or something along those lines. And really what we always talk about is the importance and the benefits of being proactive with your ergonomic initiatives, that the ideal is actually to step into a truly proactive role and start to manage these issues before they even occur. And I really do believe that ergonomic design, right, putting principles of ergonomics into your design projects or the phase of your design project is really going to be the best way that you truly jump into a proactive role. So this means that before you install a new piece of equipment, before you buy a new tool, that you are considering the ergonomic elements associated with that and whether it really is going to benefit your employees the way that you would like it to. And so ultimately that's sort of how we get truly sort of on the most proactive side that we can. Now that said, I'm going to talk about it as if it's easy and simple, but we know it's not, right? That this is a huge shift for a lot of folks because many of you who are online with us today are health and safety individuals, maybe return to work folks. There are some occupational health nurses online today, and obviously your role often is in management of injuries, right? Is on the back end. Is your numbers and your statistics you're working towards are the ergonomic injury prevention, or MSD prevention, and that is almost always, I mean not always, but is frequently in a reactive role, right? You might get a little bit proactive with some risk assessments, but ultimately it's because you've already identified that there's an issue on this job that you don't want anyone to get injured at. You know, there's a likelihood that they will, right? So that's sort of already in the reactive nature because the issue already exists, and we're trying to manage it. Getting truly proactive is managing it before it even shows up at your work site, which is what the ergonomic principles of design really does for you. So the way I want to sort of structure the webinar today is I've sort of broken it down in terms of I want to talk briefly about ergonomics and design, just an overview of that. What does that look like? What does that mean? What sort of stages of a process are we talking about? And then I've sort of geared the rest of the webinar on the how-to, right? So how do you do this? I'm going to talk about how you build this into your existing systems, right? Not reinventing the wheel, not starting from scratch. And a key component of this is going to be training the key players, right? Your engineers, any kind of individuals involved in the design phase on how to do, ultimately how to practice ergonomic principles or how to include ergonomic principles in that. And then I want to focus on briefly about sort of as part of the how-to, I guess, is the tools that you can use or put in your toolbox in order to help you be more successful with your design interventions, right? Getting involved in the design end. So that's essentially how I've structured the webinar today. I'm going to be trying to be really mindful of time. I know it's that time of year for a lot of folks where they're really busy. So I am going to try and be done about 10 minutes before 3, just to make sure that everybody has a chance to ask questions and get off to their next meeting or whatnot as they need to. All right. So let's talk about ergonomics in design. Ultimately, when we do a design review, I know that diagram's a little bit blurry, but this is often what we get, right? We actually work with design specifications. Someone along the way, a technician of some kind or an engineer has basically created a spec or a drawing that describes how they're going to fit all of the pieces of equipment and devices and systems into the allotted space that they have in order to make that happen, right? And ultimately, we take those design specifications and we break it down, trying to figure out, A, where do you put people? Because that's one of the key components is where do the people go in this system, because they are never included in the specification. And then once we figure out where the people go, we have to talk about and look at how are they now engaging with the system, right? Yes, there's a machine there, but what do they do that with that machine, right? Do they have to access it only when they have a problem or when they're troubleshooting, right? The machine goes down, that's when somebody has to get in there. Or are they putting a part in or several parts in every 30 seconds, right? Or is it something that they set up and don't come back to for 3 or 4 hours, right? So it takes them 10 or 15 minutes to get something loaded, but then the machine runs for a couple hours before it's ready, and then they come back to it. All of those sort of factors are going to determine how or what ergonomic principles we include, and ultimately which ones are most important, because the frequency of access does play a role in this, right? If somebody only accesses it on very rare occasions, like weekly or monthly, then the ergonomic element associated with that is going to be lesser because the frequency is lesser, right? So we need to first start just with a basic understanding of what is this system, and ultimately how do people engage with the system, because that is the whole part about ergonomics, right, is the human-machine interface, whatever machine you're talking about. It can be a lift assist in the hospital environment. It can be a manufacturing assembly line. It can literally be anything. And then how does the person actually have to engage with it, right? And that's really what we're focused on in the design phase. So some common issues that we see a lot of when we're doing any design reviews is that we see that the reach distances are too far. So this may require bending of the back or extensive reach, which ultimately is inefficient, right? Sort of part one is that it's inefficient. Part two is that anytime you have to reach outside of arm's length, you start to bend, therefore you're increasing risk to the shoulder and the back, right? So reach distances are a very common issue, and they're typically associated with layout issues, right? That someone has, as an afterthought, has thought, where do I put these part bins? And they've put them wherever they fit, not necessarily in a space that is the right height or layout for these individuals. Another very common issue is working heights, right? So we're often looking and considering the working heights. Are they too high for the individual? So we're looking at things like manufacturing lines. You have multiple workstations with multiple different size parts. How do you make sure that each person along this line is working as close as possible, not always realistic to work perfectly, but as close as possible to what we would consider quote-unquote ideal, which I'll get into a little bit more later about what that might be. One of our big challenges is part size, right? That sometimes, in fact, the most recent ones I was doing are about small parts, right? So they're looking at something that goes into your vehicle. It's the size of a, 4 inches by 4 inches. It's pretty small in the grand scheme of things. And so size of that part was really a minor issue. But Chris and I both worked on a project recently where the pieces, it's not really a part, they weren't doing a manufacturing line necessarily, but the pieces being handled as part of this process were massive. They were 42 inches high, they were 50 inches wide, there were 2 people that were required to handle them, and that part size has a huge impact on how they, what height things need to be at, how they engage with the equipment and the machine in order to successfully get that part out and manipulate it in the way it needs to be manipulated in the safest and healthiest way possible, right? So working heights are often a major issue. I put in too high because I think too high is more commonly the problem than too small or too low, but they could easily be too low as well, right? So another manufacturer I work at, occasionally they have conveyors that run over walkways, which makes sense. They have 2 machines that need to be, the parts need to go from machine A to machine B, and so the conveyor runs over the walkway. Really a non-issue unless someone has to access that conveyor. And in some circumstances I've watched people have to take every part off that conveyor, which quite honestly at a 5'2" female, which is what I am if you've never met me before, I'm not even sure I could reach it. So clearly that's not the ideal layout, but along the way someone has thought I need to get this from machine A to machine B and said, okay, this is how it's going to work, and never really thought in detail about how the employee is going to engage with this product, which is obviously a major issue. We see a lot of lab-type environments. That is, we work with a pharmaceutical company. We're in labs a lot. It is not uncommon for us to find lack of legroom for computer users. So they've done a decent job of laying out the lab and the various equipment and hoods and whatnot that need to go in there, but forgot that someone has to put a laptop on one of these tables and sit to use it. And so ultimately there's no leg space, or it's very limited, and the individual can't get their legs under the desk. And that instantly creates an ergonomic issue, right? Now they have to sit back 12 inches or more from the desk, and that's going to cause them to lean forwards and reach, etc. Not the fact that they're even just working on a laptop. Now they don't have room to get their legs underneath to get into better position. So lack of leg room or foot room or anything else, right? If you want someone to stand closely, can be a major issue. It's not uncommon to see racking heights, right? Going back to working heights here again, racking heights are very commonly outside of safe ranges, and it's a maximizing space issue most often, that they need X amount of space or storage area for parts or boxes or supplies or whatnot, and unfortunately in doing so often end up outside of safe ranges. Then we also look at the push-pull forces, or lifting and carrying, sort of any manual material handling type forces or weights to move a cart, pull a lever. Sometimes they're too high, they require too much force, like you have to travel up a ramp as part of the system. Again, pieces of the puzzle that don't necessarily get considered in the design phase, right? That they've got all their equipment in the place that it needs to go, it all fits, it all works, and it functions together, but they've forgotten that someone has to actually use a piece of equipment, like a cart, in this space, and ultimately that creates some challenges. So ultimately the goal for most engineers and designers is that they have a limited background in human-machine interface. In my experience, these individuals, although well-intentioned, really their focus in their education would have been on how to make it work, not necessarily thinking about how the employee is involved in the design, the layout, and the setup. So they may have had pieces of courses, maybe on the sort of outside one, maybe 2 courses touched on human-machine interface, but it's going to be pretty limited in terms of their exposure to this. So they are very skilled at making sure it all works and fits, not as skilled about thinking, this is not part of their practice to think about how the person actually engages with the machine, right? So ultimately that means that they don't think about the ergonomic principles because they aren't thinking about how the employee engages with it or interacts with the equipment. And that is where the gap typically occurs, right? Is that you get this fabulous new piece of machinery in, you've been really excited, it's going to make the job easier, and then you get it in and realize, yeah, okay, it makes the job easier. However, it has created some other issues that you perhaps hadn't thought about or weren't prepared for from an ergonomic perspective, because no one thought about how to include or how to evaluate ergonomics as part of it. So it's important that we acknowledge those factors, because otherwise we create issues that would otherwise have been avoidable, right? Like anytime I come in to do an ergonomic assessment because you believe that there's a problem, if we had been involved in the design phase, in theory, the problems that we're identifying now would have been eliminated. Right? And I think we probably would all agree, and this will come up on a slide here in a minute, that typically fixing it after the fact is way more costly than fixing it up front, right? Just like anything you do, any home renovation, any project design that you will do at work, if you fix it in the design phase when someone is picturing and envisioning how it's going to go together, it is cheaper to make changes then than it is to make changes after the fact. Pretty much always, right? It's incredibly rare that that's not the case. And often retrofit changes are not ideal, right? Retrofit changes have to work with existing systems and structures the way they are. And so sometimes we have to make do, ultimately, instead of develop the ideal, which is what we would do or work towards in the design phase, right? So we sometimes still have to sacrifice, but we are typically much closer to the ideal when we get the opportunity to work on this in the design end of it. Right, so I don't want anyone to think that I am bashing or negatively here about engineers and designers, because they are incredibly skilled and talented at what they do. They just don't have the tools in their toolbox ultimately in order to think about human-machine interface. Right? And it is interesting. I mean, I think stereotypically these individuals are often male in nature, and that often plays a role as well, because not all of the workstations that they are designing are going to be for males only. So traditionally males are stronger and they're taller, right? That's just a sort of an anthropometric body size and shape thing, right? So if your engineers and designers are 95% male, which is not uncommon based on my experiences, they, like everyone in this world, they picture themselves working at that workstation. While if you have a 6'2" male versus a 5'2" female like myself, what fits for them, even if they think about it, right? Even if they take a second and think about how would I engage with this machine, they're thinking about typically themselves. And that means that they may not be designing for the average either. They think, oh yeah, that would work for me, right? But they may not be the average person that's using the equipment, right, which is also a challenge. So there are lots of issues associated with this, and there's reasons why everybody struggles to figure out how to build this in, how to make it work on multiple levels. So obvious advantages or major advantages to building ergonomics in up front is that if it's major time savings, right, if we can design out the issue beforehand, we're not wasting time retrofitting, changing, reevaluating, right, so there's a major time savings. Increased productivity is key, right, that essentially I call myself an ergonomist. I am an ergonomist, right, I'm a certified ergonomist, but ultimately, I'm also, quote-unquote, an efficiency expert, right? Because my goal as an ergonomist is always to reduce movement, essentially. If you move less, right, then really you're saving movement, you're saving time, right, which makes you more productive. So if you look at, like, if we were to do a time study of a workstation, right, of a task, ultimately, I'm going to look at time that is quote-unquote wasted. So anytime you reach beyond this distance, then all of that extra reaching is wasted time, right? And any time that you bend further than this distance, all of that additional bending is wasted time, right? And so all of those things impact productivity. And then on top of that, if you have a task that's challenging to do, so if you have, let's say, a blind assembly, right? So you have to do some kind of assembly where you can't actually see what you're doing, right? That you're doing it by touch and feel. You're going to have more errors. It's going to take more time, right? Because someone hasn't thought about how the employee or the individual has to engage with this equipment and tools in order to build that piece or attach that piece to the equipment. And so increased productivity can happen in many ways, but it is a huge bonus of being more proactive, right? Is that the more of these issues that you design out, the more productive your employees will be, right? The better your numbers are, and that's a language that your engineers and technical people typically speak. They are focused on productivity increases. That's one of their major goals, and efficiency ultimately go hand in hand, right? So if we can work on those things up front, then we're ultimately saving a lot of time, energy, and pretty much money. Other benefits, obviously, of building ergonomics in up front is reduced injuries. If we are more efficient, right, with our movement, then we are less likely to be in postures or outside of specific ranges that will potentially increase our risk while we're doing something. We are going to design things that are easy to move, that have assists in place as we need them, right? And we're going to save a lot of time because we're going to avoid redesign. And ultimately, what all of these things and any other advantages that you can think about when it comes to ergonomics have a common theme, and that is that they always cut costs, right? That all of those things, if you can save time, increase productivity and efficiency, reduce injuries, keep your experts on the job, avoid redesign, all of those are cost savings methods. So ultimately, building ergonomics in up front has some very distinct advantages, all which connect back to cost. So that's a key thing that we're working with a few clients on, is how to figure out trying to work with them to help them figure out how they demonstrate the cost savings, right? Because preventing an injury is a subjective number, right? Because I don't know for sure how many injuries will happen on a specific job. We can use historical data to estimate what that is. But ultimately, where I can absolutely demonstrate numbers associated with cut costs is if it's an assembly line, for example, and now it takes me 25 seconds instead of 30 seconds or to 28 seconds to do a specific task, that 3 or 5 seconds of savings adds X number of parts per shift. Right now I can make more in a day, and so the time savings translates directly to cost because I can build an extra 50 parts in a day, and that is a huge advantage, right? In a week I'm building, I'm building an extra 250 parts. That might be, a huge advantage for some of these companies, especially where they're super competitive. If they have a lot of competition in terms of other companies doing similar things, the more cost effective they are, the better, right? So there are a lot of huge advantages to getting ergonomics built in up front. So let's talk about how we do this, because that's sort of the next big step, is that it all sounds fine and fabulous, but how do we actually make this happen? And the reality here is that I want you to build this into your existing practices. So many of the times, you've been on a webinar with us before, you've probably heard one or multiple of us say the same thing, which is that we don't want you to reinvent the wheel. I don't want you to start from scratch. You don't need to, and quite honestly, you shouldn't. Adding a new process or a new checklist, a new sheet, etc., into the system and asking someone to complete it is not necessarily the most effective way to approach this, right? You have systems in place. Your engineers are going to have a checklist. Right? They're going to have checks and balances that they need to do, forms they need to fill out to make sure that they get all these things accomplished, and that they ultimately have sign-off at every level to make sure that they're not making mistakes or errors, right? That someone is, or that they are, or someone else is, confirming that the work that they're creating is accurate, because that would be another huge issue. If you got a machine in that was not working because it was poorly designed, that's a problem, right? So there are already checks and balances in place for these folks. So what we want to do is work with them in order to add an ergonomic component to this. And it doesn't have to be super onerous. I don't want them to have to add an entire phase to their project, or I mean, if they do have to add a phase, I want it to be a simple one, right? I don't want it to be something that's going to slow them down significantly. If you've met these folks, they often are tight on time. They got a lot of projects going on at the same time. And if something's not going right, they're really having a bad day, right? So you want to make sure that your ergonomic design and considerations are part of your engineering checkpoints that are already happening. And to do this, the trick here is that you really need to spend time with them in their system figuring out how they do it, right? Because every organization, every company, and every department, engineering department or automation department or whatever you have, does this a bit different, and their checkpoints will look differently. So I don't actually think this is a one-size-fits-all system. I think you're going to work with this department. I think you're going to look with them and work with them to figure out what design considerations, what they're doing already, and where ergonomic design considerations can fit into their existing system. Right? The trick here is obviously that it's not just a checkbox on a piece of paper, right? We've seen that before where someone along the line has thought, okay, we're going to build ergonomics in, and they have added that the engineer has to check off that they've considered the ergonomic implications, right? That they've thought about how the human interface, machine interface will exist. Great. But if there's no actual steps in the process, then you'll get a lot of those boxes checked off, and you'll come back to them and say, okay, so what factors did you consider, because we're having some major issues with this, and they give you a very generic response, right? That they don't actually have a good answer, because they quite honestly, yes, there's a check and balance in place in theory, but the reality is that there is nothing, they're not specifically trained for this. They don't really know what they're looking for. They're estimating and they're doing their best with the information that they have, but without any kind of system in place, they don't really know what they're looking for. And so they check the box because, yeah, they thought about it, but it doesn't mean that it's actually evaluated in any way. So what I'd like to see instead is that, yes, there's a checkbox that says it's done, but that it's not that you've just considered it. It's that you've completed a checklist or a tool, or you've run it through some sort of software system if you have that technology available to you, whatever it is that can be built into their existing practices. Right? We want to provide some sort of assessment tool that they can use for their check, right? And this can look different for every company, and quite honestly, it probably should look different for every company, because you all work with different products, tools, equipment, right? You also all work with different programs and systems running in the background that your engineers are designing with. So you want to make sure that this really does fit their needs. So you might look at some, I mean, I threw this together as part of the prep for the webinar, so this is by no means a fancy or exhaustive list, but just give you some ideas of the kinds of things that should be included or could be included in a checklist, right? So you look at sort of categories. You talk about vertical height or manual material handling are the two I've selected. In some cases, these won't be applicable at all, and the engineer or technician could just move on. In some cases, these will be incredibly important parts, and they're going to want to spend more time on. Right? So I gave you some examples in terms of vertical height. Can the vertical height of the material being handled be adjusted or be designed to be adjustable? Because that's the gold standard, right? If you want everybody who works with that piece of equipment or tool or part to be able to adjust it to their own individual body size and shape. I'm 5'2". My 6'2" counterpart probably shouldn't work at the same workstation as me, right? That we are different in height, and as a result, we also require different working positions, and that can be done in many ways. but one of the sort of gold standard is that it's height adjustable. So if the conveyor is height adjustable or the system's height adjustable, that's kind of the ideal. And if it's not, or it cannot be adjustable, because sometimes it can't, right? You have 40 people on an assembly line, you can't adjust every individual workstation. You pick a height, you go with it, right? Then you start to talk about, is it within an acceptable vertical range? And I've thrown some numbers in here. These may not be applicable depending on the workstation and type of equipment, et cetera, you have on there. But it is sort of commonly that frequent work is done as close to between elbow and knuckle height for most individuals. And that's somewhere around that 37-inch mark is sort of ideal. And then infrequent work can happen as far as potentially as far as shoulder height or as low as knee height. So something you do infrequently is okay to be done outside of those ranges. But if it's heavy, there's other factors, right? If it's heavy, then maybe it's as close as you can get to that ideal is better, right? But these are some examples of the kinds of data that you may want your engineer to be thinking about. You may want them to look at this and go, yes, I did that. Yes, I considered that. No, that's not possible. This is the height. And like literally fill things in. I measured this to 36, I've designed this to be 36 inches or 38 inches was the lowest that I could get this to and still fit with the existing motor, et cetera, below the assembly line, for example, right? So you want them to have at least thought about the layout. Because I've been working with one client specifically on their design issues, and what's happening in there is that their design team, whenever they have a question, is going to the health and safety manager and saying, okay, what height do I design this at? They're a step ahead of the curve when it comes to actually thinking about ergonomics when they're designing it in, but the problem that they're having is that the engineering team is not capable, qualified, or willing to make that call, right? So they are asking for help, which is amazing because a lot of places are not. They are asking for help. But ultimately what we want to transition to is that the health and safety manager is not the expert on this, right? It should be pushed back to the engineering team so that they don't have to track him down. And if he's away, what do? They don't want to have lines showing up that aren't the right height, right? And so ultimately we want to start to shift that responsibility back to the people who are actually designing the equipment, right? And I've given you some manual material handling examples as well. Would a lift assist or other MMH device be beneficial? If yes, has it been implemented? Has sufficient space been allotted? So the things you'd be looking at there are, do they lift things? Do they have to push a cart? Do they have to move this? Do they have to lift a box that's more than 10 pounds? You can give them all kinds of criteria that's relevant to your site because that's sort of the key, right? I've left this very general. But if I was at a site that made a similar part or product at many of their workstations or work areas, I might actually build some numbers into this, right? If this is greater than 30 pounds, have we considered a lift assist or other manual handling device? If so, has it been included, yes or no? If not, why not? What are the sort of limitations? Have we allotted space? Because that's another issue, right? We often hear that's part of the retrofit is that we want to add in a height adjustable rotating pallet stand, for example. A great tool. Problem, it requires a fair bit of space because it's a square and it rotates, right? So it really needs from point to point space, not from side to side. So it's actually quite a distance that it's required in terms of clearance in order to do the rotation. So a lot of designs don't have sufficient space to add in this pallet stand, right? So just as a quick example, right, that there can be some limitations from a space perspective that we need to be addressed in the design phase so that these pieces of equipment, although easily retrofittable, you can always put a pallet stand in later, that there needs to be space in order to make that happen, right? So that's where the limitation may come in. Right? So we want to just think about what these things are that are relevant to our work site and include them into some sort of checklist or check sheet or various components. It might be these individual pieces like this may be built into different sections of your process depending on where they fit into the system, right? If your engineers build in stages, right, you may find that vertical height is most applicable in early stages, whereas manual material handling is a late stage assessment, right, that they're evaluating that at a different stage of the process. And that's great. You just need to realize where does this best fit in and work either to put it all in together or in its individual pieces, right? But it's key that it finds a home in there somewhere. So in terms of training, this is something I just, we've been talking a lot about lately, and as there's been some new research related, and sort of the overall message that I have been sharing with my clients is that we don't want to train your engineers, your technicians to be an ergonomist. So often I think that's the mistake, right, is that we're trying to teach them to be me, ultimately. And I got news for you, they're never going to be me. Not because I'm super fabulous, although I am probably, but more importantly because they have a whole ton of highly technical jobs to do, and being an ergonomist on top of all of those things is not going to happen, right? It's just not. And they're you know, it took me a lot of years of education and experience to be able to address the ergonomic issues that are present at workstations. They don't have time, energy, or in many cases desire to do any of that, right? So what we need to do instead is try and figure out how we can best train them and make it easy for them to use the basic ergonomic principles that are present. They need to know the basics. They need to know the basics of hazards, how they're relevant in their role. So how does it apply to design specifically? So giving them, you know, they want a number, and we know that there is no magic number, right? That there is no magic weight limit for a lift. There is no magic height for certain things. You know, that there are ranges, there are ideals, they're working towards. But, you know, we are realistic about systems as well, right? That they are tricky and complicated, and it's hard to fit it all in. So we want to make sure that we're not training to be an ergonomist, because that's not going to work. Put it in the classroom for a day or a week and trying to teach them how to use all these ergonomic assessment tools, right? Teaching them how to use the Liberty Mutual tables to evaluate lift, or ANSI to evaluate posture, or the strain index to evaluate hand-wrist postures. I got news, is never going to happen. They're going to sit through that training and they're going to go, oh, that was interesting, and they're never going to pick up one of those tools again. 99.9% of them are never going to pick up that tool again. So yes, they now have maybe some increased knowledge, but are they using it? Probably not. They don't have time for that. They don't have time for extra checks that are that. They could be very time consuming. It can take me days to do an ergonomic assessment of a full ergonomic assessment of a design, right? So they don't have time for that huge of an investment. What they do need to have time for is a check and a balance, right? And that's where your checklist or your systems built into your existing practices are ideal, right? They definitely need to know the basics of hazards and how they work, right? But there's a lot of limitations aside from that about what else they need to know. So I want you to incorporate everything into their system, which is essentially what I've said from the beginning. The keys here are to use their language. Speak their language, not yours. So often in the health and safety world, we talk about injury prevention, right? Engineers, quite honestly, don't give two hoots about injury prevention. That's not their targets and their goals. When you look at their goals for the year, injury prevention is not going to hit their list, right? It might hit yours, right, but it isn't going to hit theirs. So when we talk about it, yes, we know injury prevention is going to be a benefit of designing out some of these injuries and these issues, but ultimately when you want to talk about with an engineer or sort of on that end, is the productivity increases, is the efficiency increases, is the quality increases. That's the language that they speak, right? They speak quality, they speak efficiency, they speak productivity. So we want to make sure that we're using their language and using their system, which means that we build the ergonomic component into their existing system, right? They will gloss over looking at ergonomic tools and opportunities, right? They just don't, it's not part of their language. They don't think about it every day. It's not part of their world. It's like trying to teach me to be an accountant because I happen to own a business and have to do some, accounting elements. Trying to teach me those things, I don't get it. I don't get all of it. I mean, I get bits and pieces. I understand the basics, but I certainly can't apply all of it in the way that, an accountant can, right? I don't need to know it in that way, and ultimately you shouldn't try and teach them or expect them to know it in that kind of detail either. They need to know the basics. They need to know how to use it, and the better you speak their language, the more likely they are to understand, right? So ultimately, we want to teach them and train them how to use those basic principles. So they need to understand what the hazards are that are present, and we need to start looking at what are some tips and numbers and et cetera that we need to be working towards, giving them some basic systems on how to make it work ultimately, to fit it into the existing system. So some additional best practices, if I was to actually do a training, and this, we have been doing some of these with some of our clients, if I was to actually do a training, what I'm recommending right now is that we do a combination of theoretical and practice. I actually think a really effective training process for this type of an environment, so that if you're working with your engineers and your technical individuals on design elements, is to give them the theory, right? They still need to know what the hazards are, et cetera, how they apply them, whatnot, but forget to try and train them on how to use the actual ergonomic assessment tools. Instead, work with them, up front, you're working on figuring out how to best build ergonomics into their existing practices, and you're building it in, right? You're building the framework that they're going to work within that is already within their existing system, right? And then ultimately, you're going to follow that up with some serious practical examples. If your engineers or anything like the engineers I've met in my career, they tend to be very hands-on people, right? They like to do, right? That's why they chose this profession in the first place. They like to get their hands in there. They like to start designing and playing and seeing how it works. So a huge component of training for these people should be practical, right? Put them through, ultimately, use a real-life case example that you have. So you've had a line installed, you're having issues with it, pare it back several phases, right? So pull out the design specs and work with them on how to, if you essentially following your new system, right, that has checklists and checks and balances in place, how do you actually build that into your system? So now that you've got these checks and balances in there, let's go back and how would we have changed this design using those checks and balances? This is even better if you can work as a one-on-one, right? Because oftentimes your engineers are going to be working on individual projects, right? They may have a small team working together, but ultimately they kind of all have their own individual responsibilities. So you might even be able to do this from a one-on-one perspective and find that the most ideal, right? But all of it needs to include real-life examples. If you can work through stuff that they're actually working on now and showing them what would happen if we didn't make any change, what are the things that we're talking about being issues, and what would happen, what change can we make to make it better, ultimately we can show them sort of the positive impact that we can have and perhaps get some more buy-in, ultimately teaching them to use the system that they are going to be using moving forward, right? So we're going to teach them to, use the tools that have been developed. So that said, tools for your toolbox, right, or for the engineer's toolbox, it's really going to be looking primarily, most of our design elements are about anthropometrics. They're about body sizes and shapes, so about how tall people are, how far their reach is, shoulder height, head clearance, right? That's really what we're looking for when we're looking at a design, because that's all I can look at. Right, I'm going to take the measurements that you've designed. How high is this workstation going to be? How much? What are you putting on the workstation? How does that impact height? What's the ideal sort of working range? And I'm going to use the design anthropometrics in order to evaluate the heights, reaches, et cetera, that you've built into your system. Right, so anthropometrics is going to be the key component throughout all of our design pieces. Ultimately, anthropometrics is a big fancy word, but really all it means is body sizes and shapes. So it uses a standardized population. Typically that is, historically, has been, at least the ones we use here, are North American in nature, oftentimes military, so keep that in mind, right, that this is perhaps not representative of your specific work site either. So if you need to make sure that you're using the standard that most applies. So there are European standards, there are other different standards that you may want to look at depending on what your population is, right? A couple of my clients have very few what I would quote unquote North American population, like their demographic isn't North American, their demographic is Portuguese. They have 80% of the people at their work site are Portuguese. Different demographic in terms of height, in terms of reach, and so you want to make sure that you're using the demographics that are most applicable to your population. Ideally, we want to accommodate as many workers as possible. I've given you the number of greater than 95%. That is truly the ideal, but we're going to work to accommodate as many people as possible. So you're going to get a number that says the standard is that we work towards 36-inch elbow height, right? We're working towards designing things at 36 inches or 37 inches. That will sort of be the ideal. That's great. The reality is that not everything can be designed at that height, right? So now we need to sacrifice in some way. So we start to look at that, like if I sacrifice, I need to work towards 37 inches, realizing that if I'm at 34 inches, then I'm pretty close. Or if I'm at 38 inches, what am I sacrificing? What are the drawbacks of shifting, a little bit here or a little bit there? Right, because ideally we want to accommodate as many workers as possible, and the further we get away from that quote-unquote ideal, then the less people we are accommodating successfully, right? The less people that are able to do this job in the most neutral posture. I mentioned that not all of our employees fit the sort of North American standardized distribution. That is true. In some cases, and some clients in the past, we have actually gone so far as to do a demographic study internally. So knowing that their demographics from whatever city or area of a city that they are present in tends to mean that they have certain populations working there. Historically, they can demonstrate that they've had 80% Portuguese, for example, that I used earlier, right? We may be more interested in actually evaluating their own sizes and shapes of their internal population and doing our own sort of anthropometric study rather than using standardized populations as well. So there are ways to, even if you can't find a good standard out there, there are ways to use your internal population, if there's enough of them, to actually create your own sort of standard, essentially. When you look at anthropometrics, I'm going to skim back here for a second. The guys here on the left that you can see with the 3 pictures, although it's a bit fuzzy, every one of those little wee numbers and lines is measurements. So you can imagine how quickly anthropometrics becomes complicated and scary. Ultimately, what we want to focus on is that you don't want to get overwhelmed. The vast majority of time, we need a handful of measurements. There are times that I will get more technical than that and I'll break it down more, but that's a time where you need to ask for outside help anyways. If you're looking at being able to do the basics and implement the basics, then we need to make sure that we ultimately focus on some key specific measurements. So definitely shoulder height is a major factor. We want to design as much below shoulder height as possible. Knee height is sort of the other extreme. We want to design as much above knee height as possible because that minute reaching above shoulder increases shoulder risk significantly. Reaching below knee height increases back risk typically, right? Sacrifices posture. And then we also probably want to know sort of those mid-range. The ideals are more around your elbow height, knuckle height area. So if we can get those measurements, sort of key measurements for small females and tall males and get a grasp of when we want to apply some of those, that is probably the most basic 4 or 5 ergonomic anthropometric principles or measurements that you want to know about a given population. Right? And ultimately, you also want to understand reach distances because that's the horizontal element. Shoulder height, elbow, knuckle, knee are all the vertical piece, and reach distances is the horizontal piece. So you don't want to get overwhelmed by having way too many measurements. You want the basics. How do you design? Are you just elbow height, knuckle height, or so your mid-range, shoulder height, your max range on one end, knee height, your max range on the other end. And that ultimately is sort of, if you start with that and work inwards, then that can be a good point. Then the you'll see hundreds and thousands of numbers on some of these charts, and it can be very overwhelming to wade through, and ultimately, chances are good you only need 5% of those numbers. So you want to make sure that you get some very basic ones and get them comfortable using those consistently or applying those consistently in the right ways, and then ultimately the other ones become extras, right, that we don't, generally speaking, need them. It would be ideal if we got a handle on them, but if we don't, it's not going to have necessarily a huge impact on the ergonomic element. It may, but it also is less likely to. So when we're talking about, so that's sort of postural perspective. When we're talking about force, it sort of works together with awkward postures. So I've just given you a quick diagram here demonstrating ultimately that our strongest position is sort of right below our elbow height and right to our knuckle height. So this is another good sort of diagram. Simple diagrams like this would be great to put into any evaluation tools you're using for your engineering team, right? But the strongest point is sort of just below elbow height, above knuckle height. The further you get away from that, the lower the weight that people are capable of lifting. So in this case, I'm talking about lifting weights, but you can look there and see I've got my green box around that sort of close to the body, elbow height to knuckle height position. As we move away from that, so we reach further in front of the body, or we reach below or above elbow height or knuckle height, then our weight capability lowers, right? Our strength in those positions lowers. And then as we get above shoulder height or below knee height, ultimately, that's where we see the biggest sacrifice, right? That our weight capabilities in those ranges are different. And obviously different for males and females as well, right? Which is the other factor to consider. So I've given you some very basic ideal ranges. These are not really necessarily, they may apply in different ways depending on what site you're at and what you do essentially there. But the ideal range is somewhere around 36, 37 inches for sort of that knuckle height, elbow height range. Ultimately, those numbers are 36.4 is, I've forgotten which one's which, but 36.4 I think is small female elbow height, and 37.4 or the other way around maybe, is knuckle height for tall males. So if you could design somewhere in that 37-inch range, that means your tallest males aren't working below their knuckle height and your smallest females aren't working above their elbow height. And that's why that sort of range is ideal, trying to incorporate your small females and your tall males into the design phase, which is probably one of the hardest parts. How do I actually get this to work for multiple different body sizes and shapes? And then your maximum range I've given you there, 22.5 inches is your tall male's knee height, and 49.6 is your small female's shoulder height. So as much as humanly possible should be designed between that 22.5 and 49.6 range, and then ideal range is right in that middle around knuckle and elbow height. Right? So that's why those measurements become super important. And if I flip back, which I'm not going to do right now, but if I flip back, I also had the reach distances on one of my previous intro slides for this section, giving you an idea of what sort of reach distances are acceptable for frequent work or for infrequent work. And you could flip back or rewind back here and take a quick peek at those as well if you'd like. There are some other factors to consider when you're looking at design, right, that you want to think about your equipment and tools. Don't forget what goes on the equipment or work surface. And this is a common issue that we see, is that someone has designed something and forgotten that you put a 12-inch box on top of it, right? And that 12-inch box, you know, if the conveyor is designed to 36 inches, now I add a 12-inch box, I'm at 48 inches, and surprise, if I have to work to the top of that box, a small female is going to have a hard time doing that because that's basically at their shoulder height, right? So we can't forget what goes on the workstation and what equipment or tools are being used in conjunction with that, right? So we need to consider the anthropometrics but first consider all the different elements and factors, right? Is that yes, the conveyor ideally working height 37 inches, but we need to drop our conveyor height because we're putting a 12-inch box on top. So in order to make that work, these are some issues that we need to identify. Right, so I gave you my example earlier of these giant parts that Chris and I were working on a design review for, and this is a picture of one of the specs that came out of that diagram. And ultimately, you can hopefully you can see sort of the size of the part, right? It spans the entire width of that conveyor. You can sort of see the curved white section there. That's the piece that they're handling, and they ultimately have to grip, lift, and flip. And this was one of the design specs that designs that we got. And there are handle heights involved and other issues, but we worked through that with them to try and figure out what the best height is. Because this is a tricky one. This is a really tall part. It's a really awkwardly sized shaped part. So the piece going on the conveyor really had a significant impact on what was appropriate for conveyor height. And it took us some time to even think through and problem solve on how we were going to get it there and use it and ultimately make it as safe as possible for the employees. One of the other factors that we hear a lot, and just something to keep in mind, just like everything else, just because you can do it safely does not mean that they will. Right? So, for example, I just pulled a picture from online today because I couldn't think of one off the top of my head in my client files. But I have seen some examples in the past where ultimately, in theory, the employee can do it properly. So, for example, here, these two individuals are working at a bench. Let's say they're doing some sort of assembly. And again, this is probably not what this picture is demonstrating or intending, but let's assume that white table behind them is where they place the completed assembly. Totally not uncommon, right? That somebody works on a platform in a space, in front of them is their work surface, and behind them is where they retrieve parts or where they put the completed part. Ultimately, something that is 180 degrees, right, from you, which is directly behind you, is not the best position. Can both of these men use good body mechanics and turn around and put that on the table? Absolutely they can. Right? There's lots of space. They've got lots of room. They can absolutely turn around and use that table or that bin appropriately, square to it, put it in. Reality says that's not going to happen, right? Just because they can do it well doesn't mean that they will. So they are going to likely do sort of a half turn or quarter turn and reach behind their body and drop it on that table. So that means that now every time that they're going to put something on that table, they are going to be twisting, right? Ideally, everything would be 90 degrees to them, right? So they could do a pivot turn or quarter turn and be facing the end result, right? So it's facing the bin or the part area for retrieval or disposal that they need. And so they would ultimately be able to do a quarter turn rather than a full turn. Because reality, actual people say, we've seen and we've demonstrated again and again, they will not make that full turn. It just doesn't happen. So although it is ergonomically, in theory, a okay position because there is space and they're sufficiently able to do that. Reality says that they won't, right? That we've watched it happen again and again and they don't. So poor design in this case may actually limit the success or add ergonomic issues. If each of them had a table that was 90 degrees to their work area, then they would be way more likely to use good body mechanics as part of the transfer. Right, so we need to think about that as part of the layout. Is it, how do we lay this out? Is it appropriate to share a space like this, like to share a table? And if it is, then can it be designed so that there are two separate workstations and that table is in the center, right, so that they both do a quarter turn either to the left or the right, depending on what side they're on, right? There are ways to reorganize that space a little bit, perhaps to make it more efficient and ultimately reduce the likelihood of an awkward posture. So that's where thinking about how your people use the workstation and good practices that they might employ but are less likely to do so, how that is going to impact their engagement with their workstation. Other factors that I sort of briefly want to highlight here is that there are repetition issues, right? So how frequently a task is done will impact the risk and the design, right? So tasks that are done frequently need to be designed as close to ideal as possible, and that applies for, think about racking, right? You would design your racking such that your heaviest and most frequently accessed items are in the center ranges, and your lightest and infrequently accessed items are on the outside ranges, so close to your knee or your shoulder height, right? So we want to sort of think about that. Things that are done often should be as close to ideal as possible. Things that are done infrequently, sometimes, depending on the weight or what other factors perhaps, you can design them more to the maximum ranges, right? Not ideal. We're not always working towards that, but if you're stuck and you're in limited space, you're not sure how you're going to fit it all in, those are the ones that you're going to sacrifice to greater ranges. And never forget where the person will stand and how they're going to engage with the workstation, right? I did mention this earlier, right? Sufficient leg room for lab-type environments. Computers are often an afterthought because they just need to go somewhere. But ultimately, if the person has to sit or must get close to it, or the computer I saw recently, like a touchpad screen at a manufacturing facility, and it was over top of a conveyor, which in theory is fine, except like it's like a 30-inch reach to access this, and they touch it every time they have to set up a new part. It was a large automated saw. So they have to set up a new part and basically tell the saw how to make the cuts on this piece, and they have to reach over the conveyor each time in order to make it happen. Right, which is not ideal. So they create a contact stress between their body and the conveyor just to reach that far, because somebody installed the computer without necessarily thinking about how the employee would use it. And the answer is that they're not going to walk around that conveyor every time. It's several extra seconds out of their way. And again, can they do it properly? Perhaps. Are they going to? No. There's no way that they're going to waste the time to walk around that conveyor. It's just not going to happen. Right, so a better design would have been a longer arm or other factors that they could have used in order to improve the layout, right? So if we can reduce that reaching, for example, we are more likely to reduce those contact points. Other elements that we didn't talk today, but I just wanted to sort of briefly give some thought to, is that ultimately you need to be able to, ideally in a design phase, you should be able to see what you're doing, and this would be depending on what you're designing, right? Somebody who's designing a cell phone, which is tiny, and assembling a cell phone and installing the various small components, these would be questions that you would absolutely want on your checklist, right? Can the employees see what they're doing at every stage of the process? Right, and the answer needs to be ideally yes, right, because it changes the ergonomics, the speed, the productivity, the accuracy. If they can't see, they're going to make more errors because they literally can't see it, right? It's blind assembly, and that's an issue. If there's a push-pull, right, can you reach it? Is it easy to turn or push and pull? This is an example from a client we saw. They're reaching up to pull a valve. They don't do it frequently, maybe daily, maybe even every other day. But the design of that is obviously awkward. You can't see it in this picture, but there is a bench or a table of some kind underneath this, which is why he's starting from so far back. Right, so there's been a poor design. Nobody thought about where this individual would have to reach to. Quite literally, I cannot reach that lever. Right, like literally I can't reach it. So 5'2" female cannot reach that lever. So I couldn't do this task ultimately without some sort of assistive device in order to even get to that reach, because he's at maximum extension and he's fairly tall. So there's literally no way that I can get to that lever, which is a problem, right? That's a poor design element. So you need to think about reaches, and can you get it, and then can you turn it? Because sometimes they're really stiff and hard to turn as well. And the other element I didn't talk about today, but is also a major factor sometimes in ergonomics, depending on the type of equipment you're doing or assembly you're doing, is the control design, color, style, shape, location. There's tons of research out there on this. I just threw some pictures of e-stops in there, but ultimately, you know, e-stops are red for a reason, right? Red means stop, and that's a very visual color. You won't find an e-stop that's green because that's a very confusing visual symbol. They're typically round. They're easy to push. There's very simple things to them to try and draw attention, number one, and make sure that they're easily hittable if they are needed in case of emergency. So control design can be a significant ergonomic element as well, although from a design perspective, it's a little bit different. So I didn't want to speak too much to that today, but I did want to highlight that it can be a factor. So I know that's a lot of information sort of in a short period of time. I haven't had any questions pop up as we go along, but I'd like to open the floor to questions right now. Does anybody have anything they want to, a burning question they want to ask her? So just while I wait for anything to get typed in there, it looks like somebody's putting a question to me right now. Just before anybody checks out here, I just want to highlight that our 2017 webinars are not yet on our website. They will be. Just so you know what's coming, we are going to continue to offer free monthly webinars. They will still remain free. That is something that we believe education is super important. We want to share knowledge and experience and other things with our clients to help make sure, and our potential clients and anybody else who's interested in joining us, just as a way to give back to the community that obviously helps us be able to do what we do. We want to make sure that everybody gets the information that they need. So you will see some tried and true favorites coming back every year. For example, we do some office ergonomic related issues, but we have been talking about trying some new and different things this year. For example, some of the things that we're throwing out right now and we're working on perhaps moving forward with is doing some more case studies. So actually having like a client online with us presenting on what we did, what their findings have been in-house in terms of injury reduction or productivity increases or whatever, and talking sort of about both sides of the coin. So you would get sort of a real-life case study with the opportunity to ask the client about what kinds of things they've been doing. So we're just working out who might be interested in doing that and talking through it, but there will be some new and exciting things, I think, next year, not only topics, but also styles for our webinar. Okay, so question that's coming in is just asking a little bit more about training, trying to figure out sort of what length or duration of training that would be required. And ultimately, that's actually a really good question. I'm not sure that there is a one-size-fits-all answer to that question right now. Probably what I would recommend is that really we're going to spend most of our time up front trying to figure out, understand and figure out the systems that are in place in the engineering area to figure out where this ultimately where you're going to build ergonomics in, and working with them to do that, right? Not just dropping it on their plate, but working with them on how it's going to fit into the system. And then once you get that sort of pre-work done, ultimately you'll move on to figuring out how to build, how to train, what's the best approach, right? It depends on how you're going to do it. I think there's going to be a theory element, which is going to probably be half a day, maybe a day on the outside, and then you're going to be looking at the different components of this, which are going to be things like, do you want to do it one-on-one? Do you want to break it down or ask, do you want to break it down into project and work through a project in multiple stages? Because in that case, the training may look very different, right? And you may not even have to do it all in person. You might do some of that online as well. Yes, Katja, you asked a question about pre-employment testing. I think that's a great idea for a webinar. We can absolutely do that in the future. We haven't done one in a while on that. So, any other questions about today's webinar? Okay, I can see some folks signing off. I think I've reached the 3 o'clock mark, so I am going to let you go today. If you do have any questions, you know how to get a hold of me. Our email address is on the slide here, and you can always email me directly once the post comes out about the recording for the webinar. Thank you very much for joining me, and we look forward to seeing you all online in 2017. Thanks, everyone. Have a great day.